My wife and I received our Xtool screen printing multicolor kit a few days ago. Although the kit comes with fixtures to align frames when placed in an S1 or D1 laser, we want to use it with our Xtool P2 CO2 lasers. This video shows how I'm positioning the frames in the laser. By registering the frames on a set of pins, multiple screens can be aligned, one for each color. The second goal of this configuration is to make it easy to exhaust the smoke that's generated when cutting the screen on the laser. This P2 laser sits on its riser base. This allows for positioning the bottom tray into multiple positions. For this setup, I take the tray out, then turn it upside down and insert it into slot 1A. This puts the tray at the proper height for use with the frame. When inserting the tray, I push it all the way to the back and give it a push on the left-hand side, and that seats the tray square with the frame and its riser base. Yours might be a little different depending on whether or not your riser base is exactly square, but the key is to always put it in the same way, and that makes it repeatable. Before showing the way I'm registering the frame on the tray, let's take a look at a simple project to see how much smoke accumulates. This is a gear that's only about 40 millimeters wide, so it's a fairly small project, only takes a couple of minutes to burn, and it's just to see how the settings from a previous material test grid works. I'll run this project twice. The first is with the frame sitting flush on the tray, and we should expect a significant amount of smoke trapped under the frame. The second time will be after adding some 5 millimeter non-slip pads under the frame, and that should allow airflow to the exhaust. I placed the gear on the workspace and selected open plane mode, not slats flat mode. Now we specify that it's a user-defined material, and we need to enter the distance from the laser to the material. There are a few ways to do this, but let's just click on the Xtool Creative Space Aimed Measure icon and select an area. The laser head moves to that area, calculates and enters the distance measured, in this case about 62 millimeters to the top of the screen in a frame sitting directly on the inverted tray. Then, clicking on the gear to display the properties, I've set it to 28% power, 190 millimeters per second speed, and 100 lines per centimeter. I'm using the results of a previous material test array, and you can see it in the upper left corner, and it's currently set to be ignored. When we process and start the job, the laser starts to cut through the emulsion that's been pre-applied on the metal screen. Here you can see the very end of the engraving process. When it's done, the head retracts into the corner, and the exhaust fan continues to run for a while and then turns off. When I lift the frame, you can see that even though this was a very small engraving, it generated quite a bit of smoke that was trapped between the screen and the tray. My approach to remedy this is to put some 5 millimeter spacers under the frame so that the air has a way of getting below the frame, carrying the smoke to the exhaust system. I'll show the spacer installation in a few moments, but let's see the difference in smoke when the spacers are installed. Now we just need to move the gear to an unused spot on the material and remeasure the open plane distance so that it counts for the new, closer material position. And this time, the measured distance is about 57 millimeters, as expected. So let's run it again. If you watch closely, you might see some wisps of smoke exiting from beneath the frame. As before, when it's done, the head moves to the home position, and even on the end farthest away from the exhaust fan, when I lift the frame, there's almost no residual smoke. Preparing the frame is pretty easy. I chose to raise it about 5 millimeters, which is high enough to let some air go through, but still allow me to register it against the pins on one of the fixtures that are supplied with the screen printing multicolor kit. I'm using adhesive anti-skid pads. They come 3 to a pack, and they can be easily cut with a scissor to roughly 1-inch squares, and I can put them into the corners of the side of the frame opposite the screen. This also has the benefit of keeping the frames separated and avoids scratches if they're stacked for storage. I also added 2 more squares a little bit further in from the corner because when you turn it upside down on the inverted tray, the pads better match the contours of the tray. Now back to the P2 with the inverted tray. Next, I used the metal alignment fixture included with the multicolored kit that's originally designed for the S1 laser. I apply some 3M extreme tape to the underside of the fixture. I don't cover the entire area and keep the tape slightly away from the edge that will be closest to the frame. Then I remove its red release layer. The next step is to position the frame where I want it on the tray, centered between the front and the rear of the frame. Once the frame is in position, tilt the fixture slightly so the adhesive tape is not touching the tray. And without moving the frame, slide the fixture in so that it meets the end of the V-slots on the frame. Then lower the other end of the fixture so the adhesive touches the tray. You can then slide the frame away and press down on the fixture so that the pressure-sensitive adhesive will bond with the tray. So now aligning the frames on the P2 becomes a simple matter. Place the frame on the tray and the laser, slide it into their registration pins, and go process your job. I chose this particular approach because it only requires a scissor, and it's something that most people can easily do. Because I have a complete shop full of tools, I might drill 2 holes through the fixture into the tray, pry the fixture off the tray, remove the tape, and insert 2 short bolts with nuts to attach the fixture to the tray, making it easy to remove the fixture at some future time. I hope this is helpful and gives you some ideas. Thanks for watching.